Okay, today we will study about electrostatics. Electrostatics. This is very important chapter. In this chapter, first of all, we will study about electric charge. Okay. So first of all, we should understand what electric charge is. Electric charge is basically the property of an object due to which it applies some force, that is called electrostatic force, on another object. You must have seen that when you rub a comb with your dry hair and you put it near some tiny crumbs of or pieces of paper, the comb attracts those pieces of paper. So what is the logic, or what is the reason behind this? See, when we rub our hair using a comb, the comb gets charged due to friction with our hair. As a result, it applies electrostatic force of attraction, and hence it attracts those tiny crumbs of papers. So we can say that electric charge is basically the property of an object due to which it applies electrostatic force. It can be either attractive force or repulsive force. Okay, so that means there will be two types of electrostatic force. So the reason behind this is that electric charges are of two types. What are they? One is positive charge, okay, and the other is negative charge. All right. So electric charge also has some properties. What are those properties? Let's study properties of electric charge. Number one, it applies electrostatic force on other objects. All right. Number two, as I earlier said, that charges can be positive or negative. That means there may be two charges which could be either like charges or unlike charges. So if the charges are like, then the force of interaction will be repulsive in nature. And if the if the charges are opposite or unlike, that means one is positive and the other is negative. In that case, the force of interaction will be attractive. So we can say that like charges, repel each other. Okay, and unlike charges, just a second, unlike charges attract each other. Okay. Apart from this, charges can be quantized. That is called quantization of charges. What is it? See, suppose there are n electrons in an object, then we can say that Q is equal to NE, where N is number of charges and E is one charge. One charge means one electron, you can say. Okay. Next, we will study about conservation of charge. Conservation of charges. What does it mean? Suppose there are n number of charges in a system, then, and suppose in a system there are some objects, and suppose there is an interaction between those objects due to which charges can move from one object to the other, then what will happen? Charges will transfer from one object to the other, but there will be no destruction or creation of charges from outside. I mean, there will be no increase in charge in the overall system, neither there will be any kind of destruction of charges or loss of charges. Whatever can be happening is that charges can be transferred from one object to the other in that system, or you can say that charge can increase or decrease from one to the other. That's it. But charge cannot be lost, charge cannot be created. So that is called conservation of charges. Alright? Okay. The next property is additivity of charges. What does it mean? Suppose there is an object and there are some charges which you can name as Q1, Q2, Q3 and so on, right? Then the total charge in that object will be the sum of all those charges, that is Q1 plus Q2 plus Q3 up to Qn. Alright? Okay. So these were some of the important properties of electric charge. And now we will study about Coulomb's force, or you can say Coulomb's law. Coulomb's law. This law states that suppose there are two particles, two objects. Charge on one object is Q1 and charge on the other object is Q2. Let's suppose. And the distance between them is R. Then there is a force of interaction between these two charges which are directly proportional to the product of these two charges and inversely proportional to the square of the distance between them. Right? So when we combine these two relations, we find that F is proportional to Q1, Q2 upon R square. In other words, we can say that F is equal to K Q1, Q2 upon R square, where this K is nothing but the constant of proportionality. Its value is given like K is equal to 9 into 10 to the power 9. What will be its unit? So first of all, we should know the SI unit of charge. SI unit of electric charge is Coulomb. Alright. And what is the SI unit of force? It is Newton. SI unit of distance is what? Meter. So when we substitute all these SI units of all these physical quantities, we will obtain that the SI unit of K will be Newton meter square upon Coulomb square. Alright. So this is basically the value of K. In some books you will find that K is equal to 1 upon 4 pi epsilon naught, where epsilon naught is said to be permittivity of free space. We will later discuss about this term. Its value is 8.85 multiplied by 10 to the power minus 12. Once again, its SI unit will be what? So its SI unit will be, you can find on it on your own. Just substitute the SI units of all these physical quantities. You will obtain this. So it is Coulomb square per square meter per Newton. Alright. So this was about Coulomb's law.